In this video, we'll look at managing a substitution while computing a double integral. I would like to calculate the double integral of this function that appears here over the unit square with corners 0, 0 and 1, 1. So the first thing we need to do is set it up as an iterated integral. So we need to pick an order of integration. I'm going to integrate with respect to x first and then y. And then our limits of integration will go from 0 to 1 for both of those integrals. Just looking at the expression, you see x squared in the denominator, and up top I see 2x. And remember, I've got to think about y as a constant here, so I'm not so distracted by that factor of y or the y squared that's appearing in the radical. This suggests to me we should try a substitution. Let's take u to be x squared plus y squared plus 1. Its derivative is 2x, and we're talking about with respect to x because we're integrating with respect to x here. And that tells me that du is 2x dx. Now when I do a substitution, I should change the limits of integration now. When x is 0, I need to find the corresponding value of u, and if I plug the 0 in for x, I get y squared plus 1 in the original substitution. And when I plug in 1 for x, I get y squared plus 2 when I plug it into the original substitution here. So let's carry the substitution out. Limits of integration will change. I had a y up top here, and so that's just a constant, and I'll keep that. And then the 2x dx gets replaced with du. And then in the denominator we have square root of u now. So ultimately we're just integrating a power of u to the minus 1/2. Again, y is just some constant here. So we go up a degree and divide by that new power 1/2. And we need to evaluate at these limits of integration, which are these functions of y. Let's simplify a little bit. So we're really looking at 2 times the square root of u. Again, y is just a constant in front. And we're going to evaluate that square root of u at each of those quadratic expressions. So y squared plus 2 and y squared plus 1 go in for u. And we have a very similar looking expression here. I've got square roots in both terms. Notice it's a quadratic underneath, and the derivative of that quadratic, 2y, is sitting outside. So let's write it as a power. And you could do substitution again, but I'm writing it out without a lot of those details. If I just go up a degree here, I'm at power 1/2, and I go up to degree 3/2, I'll have roughly the right expression. And if I was to differentiate this expression here, I would get a factor of 2 times y, and that's already in the original expression here for us. So a little bit of a substitution, but just done in place. And you can check the coefficient here. The 2/3 is coming from the 3/2. So just differentiate this and see that you get the expression that's above. And that needs to be evaluated at 0 and 1, and it's just a matter of plugging in values. So the first term we plug in 1 and 0, and so I get 3 and 2, both to the power 3/2. And then we'll subtract. And I've got to plug 1 and 0 into this term here, and don't forget to distribute the minus sign through each of those 2 terms when you evaluate. And then finally just simplifying the expressions, rewriting them as radicals, and combining some of the like terms that show up, and there is our final answer.